P.3 Functions and their graphs. Example 1, sketch the graph of each equation. I made my x and my y axes, and the idea would be that you'd make either a table, which you should know how to do. Of course, write your little table, x and y, and then pick a few values. You normally want to take a couple of negative ones, and then a few or a couple positive ones. And then you plug them into the equation and you get your y values. Like so, right? Plug in -2, -1, 0, 1, 2, and you get -3, 1, or sorry, -3, -1, 1, 3, and 5. Now, I can sit here and just plot these points, or, of course, you do learn how to read the equation and the information in the equation. For example, this is the y. So here we have our y-intercept right there. Sorry, I wrote over it. And then the number in front of the x, the coefficient of the x term, that would be, and hopefully you're saying right now, slope. So with these two things, we do have enough information to graph the equation. So no big deal. I'm going to go ahead and draw some tick marks on here. Please don't judge my lines. They're not very straight. So the y-intercept is 1. So here we go. And then my slope is 2, which basically means I'm going up 2 spaces over to 1 space, right? So up 2 spaces over 1. So about right here. And then I could continue in that direction, but since I didn't make a really long graph, I'm just going to go backwards. So 1 to the left and down 2. And there's my other point. And that is actually enough to make a line. So I'm going to draw my line now. So there's my line. And nothing else to it. Okay, B. This is in point slope form, but you could still get information out of it. For example, the 3 in the front there of the parentheses, that is your slope. Let's see. So this right here is slope. And then since this is point slope form, you can actually figure out what the point is. And so that would be this number and that number. The 1 is actually the y, and it's supposed to be positive. And then the 4 is the x, and it should actually be negative, the opposite of what it looks like in the equation. So then we graph the point, -4, and then 1, right about there. And then we use our slope to make at least one other point. 2 points is sufficient to make a straight line. The slope is 3, so we go up 3 spaces. Wow, my lines are not really straight. And over 1 space, right there. And like I said, sufficient to make a line. And there you go. Example 2, for the function f defined by f of x equals x squared plus 7, evaluate f of 4. So I'd hope that this is like, oh my god, this is so easy, you're just plugging in. But I'm not really teaching you that. I'm just reminding you, evaluate f of 4 means, yo, your x is 4, plug it in. Okay, because sometimes it's the easiest things that we forget. So the 4 is your x value. Okay, so I want you to remember that. Okay, so I do actually want you to use proper notation. So f of 4 equals, and then you would take your equation and plug in your 4 plus 7, and then so 16 plus 7, and then that's 23, and that's it. Okay, example 3, use the graph to answer the following. So here we're talking about domain and range for the first one. And because there are two, what do you call those? Curves, lines, graphs. I think that for the sake of this example, I might just color one of them, or maybe both of them, so you know which ones I'm looking at. Okay, so G is going to be the red graph, and F is the blue, the highlighted blue graph. So A says identify the domains and ranges of f and g. Now, if you don't remember what domains and the domain and the range are, on the left of your notes there, in that left column, you can certainly write down the domain is the lowest to highest x value possible for that graph. So again, the domain is the lowest to highest x value. The range is the lowest to highest y value. So when you're looking for domain, you want to focus on left to right. And when you're dealing with range, you're going to focus up and down. Okay, so A, identify the domains or ranges of f and g. So for f, if we look at f, the lowest x value for that graph is here, right here. From left to right, that is the lowest one, -4. Now, the highest x value, remember left to right, if this is domain, I'm focusing on the axis. From left to right, the biggest x value for this graph is right here. So my domain is from -4 to 4 for f. So this is for f, and domain is -4 to 4. And those are brackets. Now range. The range for f. So to do. Now, what is the lowest and the highest y value? So now we're looking up and down. So look at the y-axis. Look at those numbers. So right here, this is the lowest y. And then going up, this right here is the highest y. So that would be -3 and 5. So from -3 to 5. Okay, so now repeat with G. Try to see if you can figure it out on your own real quick. This would be a good chance to pause, if you need to. Okay, so the domain for G, right, that would be the highest x value. And the biggest x that G encounters is right here. Okay, right there, which is +3. And then the smallest x value is right here, which is -3. So from -3 to 3. And yes, you normally do write it from least to greatest. Okay, and then the range for G, that would be the highest y value and the lowest y value. So the lowest y possible is -4, and then the highest is +4. I apologize again for my lines not being very straight. Hopefully that's what you got on your own. Okay, B, identify f of -2 and g of 3. Now we don't have any equations, but the idea is that if we did have equations and we were to plug in x equals -2 for f, we would get out a y, right, our output. And so we're just asking, or they're asking for us to tell us what the y is when x is -2. And again, this is just all review. Okay, so x equals -2. Here's -2. Nope, I can't write. Here's -2. So for f, f is located right here at x equals -2. And the y value is -1. So f of -2 is -1. So now for g, so g of 3, so where's 3? Here's 3. So for g is located down here when x is 3, right? So then that means that the answer is -4. Okay, C, for what values of x is f of x equal to g of x? Now, if you remember this from Algebra 1 and I believe also Algebra 2, oh yeah, and even pre-calculus, equations, functions, they're equal when they intersect, their graphs intersect. So all you have to do is analyze the functions graphs here, and where do they intersect? So let me highlight. I'm going to highlight this. So right here, oh wait, wrong color. There you go, right there. That's where they intersect. And that x value is -1, and then that would be your answer. So x equals -1. Okay, D, estimate the solutions of f of x equals 2. I say estimate because the graph, you're going to have to, make sure, or figure out where the x is actually. So estimate the solutions of f of x equals 2. Okay, so now since for E, y equals 0 is this entire horizontal line, right? And G intersects this line at x equals -1. That is the solution for g of x equals 0, but it is not the only one. Um, because g also intersects y equals 0 right there at x equals 1, and it also intersects right here at x equals 2. So for E, there are actually 3 answers, and that is -1, +1, and +2, because G intersects y equals 0 more than once. It equals 0. The y value, the y coordinate um, is, sorry, G has 3 coordinates where the y coordinate is 0. Okay, so on the left of your note there, you might want to write composite functions. Um, so let's see, composite functions, and composite functions are just a function composed of 2 other functions, and that's why it's called a composite function. Um, so this notation right here is f of g, which means that you're going to take f of x, right? And then whatever that equation is, instead of plugging in x, you're going to plug in the whole entire equation of g of x. So we do need this skill, or at least we need to be able to work this skill backwards in calculus. So f of x is 2x minus 3. So if I want to do f of g, I'm going to do 2, right? Forget the x, minus 3. And then now I'm like, okay, well, if I didn't write the x, what needs to go there is g. And what was g? G was cosine of x. So cosine of x. And there you go. That's it. That's a composite figure. Or, not, sorry, composite function. And so here is the skill that you actually need for calculus. Here are 2 composite functions. I need you to figure out what the original 2 functions were that made this function. So sometimes the answers may vary, but for the most part, let's look at A. For the most part, parentheses are a good indicator that, the stuff in here, this was one function. This used to be just x, and it got taken over by this other function. And that's a good frame of mind to have. So right here, I'm going to call this f of x. Okay, so if f of x was 5x plus 7, right? Then the other function, I'm just going to call it g of x. Doesn't really matter which one is which. We're just trying to break this down. The other function, which I've decided to call g of x, is going to be the rest of it. But instead of the 5x plus 7, that's going to be replaced by just a simple x. Okay, so hopefully you could see, all right, so we started off with x squared minus 1. We got rid of the x, and in its place, we stuck this function. Okay, and that's how they made h of x. All right, B, h of x equals the square, or yeah, the square root of x minus 3. Now, just like parentheses are like an indicator that, okay, this is a function inside of a function. A square root can also be, because under the square root we have 2 terms. We have an x minus a 3. So you could think of this as, okay, so this x minus 3, okay, I need a marker here. X minus 3, let's get rid of that. And, ooh, okay, I've decided that f of x is just the square root of x. And then the other function, which once again I'm just going to call g of x, is going to be whatever the stuff inside there was, which was x minus 3. So then the idea would be that when this was composed, h of x was composed of these two functions, they took this stuff and dunked it in there and got rid of just the x. And that's it for composite functions. Okay, on the back. Here are some parent functions you should be familiar with, you need to be familiar with. I should be able to tell you, draw me an absolute value function, and you should know that that's in the shape of a v, if it's just a regular absolute function. I mean, you should know what a quadratic is. Here they're calling it the squaring function, but it is just a quadratic. And it's also referred to as a parabola, right? The cubing function, or a cubic, the square root function, and then rational function, and the most simple of the parent functions, the identity function, which is just y is equal to x. So if x is 1, y is 1. If x is 3, y is 3, etc. There will be more functions that you are supposed to know and be familiar with, but here's just some to refresh your memory. And then the basic transformations of any graph, basically, let's see, I need a highlighter. For example, this one right here. By subtracting a number from the function, I'm actually just shifting this function down, making it go down. And then the very next one, by adding a number, a constant, I'm making it go up. Now the difference between that and these two is very important. As you can see, the number is not just being added to the function, it's actually being added to the x. Or the number is being subtracted from the x. And so when the number is being added or subtracted from x, you're not going up and down, you're going left and right. And it's actually the opposite of what it looks like. If it's a negative number, so like x minus c, you're actually moving to the right. And if it's x plus c, you're moving to the left. And then also a negative in front of the function right here makes the function flip. So like for example, parabolas, which are normally this way, if it's a negative in front, it will be now like this, right? Just like absolute value, this is absolute value. With the negative, it ends up looking like this. Okay. Example 6. Sketch the following graphs. So I'm just going to make myself some axes here. Just one second. Okay, so again, this is just a rough sketch. Nobody's asking for perfection. It's just really important that you understand what the graphs look like. Like, I need you to look at this equation and be like, okay, negative x squared. X squared is a quadratic. If you don't know that word, then you really need to write it down. Okay, these are your notes. And a quadratic is any equation with x squared, and that's the highest degree exponent. So x squared, you need to be already like in your brains, okay, it looks like this. But then that negative in the front, oh, okay, so it actually looks like this, right? And then that plus 3 at the end, you need to be like, okay, that 3 means that we're going to shift the parabola 3 units up. Okay, now the negative means upside down, and then the 3 means shift 3 units up. So I'm going to attempt this. So a regular, and I'm going to draw this very quickly. A regular parabola would be something like this. Okay, but in this scenario, it's going to be shifted 3 units up, which is right there, right? So this is 3 units up, but then because it's a negative, it's actually going to get flipped down. And there you go. There is a graph of y equals negative x squared plus 3. Okay, onward to b. So I have a square root, so this is going to be a square root function, but there's some shifts happening, right? So then I need you to be like, okay, so the 4 means that my square root function is being shifted, and I'm going to write it up here. Shift 4 units, so it's a plus 4, so it's going to go up. And then, ooh, look at that little dude hanging out there next to the X. He's like, ooh, be careful. So that little dude right there, gotta make sure I'm like, oh, okay. So I'm actually shifting it 1 unit. Okay, so but which way? It's a -1. Okay, so yeah, I'm gonna shift it 1 unit to the right. Alright, so then this is a square root function, and the best way to start is just to draw a sketch of the parent function. Now, A, I didn't sketch perfectly, but B, because, I mean, I don't have to sketch it perfectly, but I am going to use the fact that the square root function, if I plug in a 4, I should get a 2, right? So if x equals 4, then I should get 2, which is about right there. So then this is what it should look like. Ooh, look, see? Not that great at it. Okay, I fixed it. Looks better now. So there's my square root function. So now I'm going to follow the steps. Shift 1 unit to the right and 4 units up. So really doesn't matter which one you do first, I suppose. Let me do 4. Up. 1, 2, 3, 4 up, and then 1 unit to the right. And there you go. There's my new graph. Okay, so I got a little ahead for example 7, and I went ahead and I graphed the parent function. Here it says sketch the graph of f of x equals the absolute value of x cubed. Now, x cubed is a cubic, and my graph here is the parent function of a cubic. And so the absolute value, what does that change? Well, absolute value means no matter what x value I plug in, positive or negative, and I can have positive or negative x values, the y values will always be positive, because if it's inside of the absolute value, there's no way that my y's can be negative. So an easy way of looking at this is the absolute value makes anything below the x-axis, right? Let me mark that. Anything below the x-axis, it makes it jump up to the top. Basically, it reflects it up. And so if I were to sketch this properly now, all of this stuff in the bottom here would flip up like this. And then this would have to go bye-bye. And then that would be my actual sketch. Okay? Alright. Please do answer the practice problems.